What's up, pre-calculus? We're going to go over two very important graphs that you might know from your past, and I'd just like to go through and identify some important information and features and the shapes of these two graphs. Okay, the first graph we're going to look at is the reciprocal function, the 1 over x function. Why don't we apply what we've learned in the past, a little continuity test here. Take out those graphing calculators, try to determine the table of values there, and determine what type of continuity there is, and I'll be right back with you. Okay, welcome back. Here I have the values showing on my calculator screen, and I have filled them into the table up above. Okay. And as we analyze this information, we get to review a little bit what we've already learned. Yes, f of 0 is undefined, division by 0, biggest, baddest rule in math, can't be doing it. Limit of f of x as x approaches 0 from the left. All right, the trend in these y values is they're getting very, very large and negative. The limit is negative infinity. And from the right, we see these y values increasing without bound, and we would call this limit of f of x as x approaches 0 from the right, positive infinity. And we know to call this an infinite discontinuity. A little bit of new information for us here. The conclusion as we start to gear up for graphing this function is we will now refer to the line x equals 0, that undefined value of x there. That is going to give us a graphical feature called a vertical asymptote. And you can see that down at the bottom of the page there. All right, let's make a new table of values here. You might want to pause the video again. And let's try to get a table of values as x gets very, very large, negative large and positive large. So please pause that video again, fill in that table, and I will check back with you. Okay, welcome back. This is what my calculator screen looks like as I have calculated those values, and we do see that mysterious capital E in our y values. So let's just, always keep in mind, we don't want to write a number as -1, capital E, -4. That is not going to be sufficiently describing the value. A better way to say that would be to write it with scientific notation. The best way to say it in terms of understanding what's really happening to the y values is to write it in decimal form. So that's what I'm showing down here in the table. As we think about what this means, just notice walking towards the left here, these x values are approaching negative infinity. They're getting hugely negative. The x values towards the right of the table in this direction, well, if that trend continues, those x values would approach positive infinity. And let's record what's happening in the y values as this trend happens. These y values getting tinier and tinier and tinier, approaching 0. These y values getting tinier, 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 tinier still, and they also are approaching 0. So a little bit of a new conclusion for us here. The limit of f of x as x approaches negative infinity, this left side here. Just note the f of x or the y values do approach 0, and they approach 0 on the other side as well. As x gets big, y gets small. The conclusion we're going to draw here about this, the line y equals 0, because remember, f of x is y. The line y equals 0 is a horizontal asymptote of this function. Again, we're gonna see what this means right down below here. So I do have this function graphed, and I didn't draw in the asymptotes, but we could certainly do that. I'm just gonna sketch in a dashed line here, the line x equals 0. That's the vertical asymptote, and let's sketch in the line here y equals 0, that would be the horizontal asymptote. In this case, our graph gets closer to those asymptotes at the end, and kind of, you might not have known what values to put there in the middle, but I was able to place these 6 points on the graph simply by dreaming up some pretty easy x values and computing the y by just performing that division. Now a bunch of these are easy. If we input -2, of course 1 divided by -2 gives us -1/2. Just to go back to elementary school basics for a minute, if I input an x value of -1/2, let's do that division. 1 divided by -1/2. Could write it horizontally, but now we know, oh, that's right, elementary school, multiply by the reciprocal, and that is how I get the y value of -2. Let's try to make 2 different transformations of this function. Let's refer back to our old transformation rules, and I'm going to put a new equation, new function, g of x equals f of -x. We know this is going to reflect our graph over the y-axis. So let's take a look at what that will do here. If I take these 3 original points from the f of x, flip them over to the y, that will be a horizontal transformation. They will plant themselves here, here, and here. And if I take these 3 original points from the graph, flip them over the y, they will land here, here, and here. So let me make a little smooth graph here. And if you do want to sketch in those asymptotes, shake your asymptotes. There you go. There we have it, a reflection over the y-axis. All right, let's try to review another of our transformation rules, and I'm going to create a new function here, h of x, which is the negative f of x, and we should be able to interpret that transformation as a reflection over the x-axis. All right, so, okay. We go back to the original function. I'm going to take these 3 points here, reflect them over x, and they will land down there in quadrant 4. And I will take these 3 points down here on the original graph, reflect them over the x-axis, and they will land up here in quadrant T. And we make our little graph there, and life is looking good. If you want to shake your asymptotes, we can sketch them in here as well. Beautiful. Well, I think you guys might be seeing the same thing I'm seeing. There's a bit of a conclusion we can make as we compare the 2 transformations we just looked at. Seems to me, and I hope you see it too, the graph of g of x equals the same exact graph of h of x. So think about what that means. G of x is f of -x. The second graph we did was the negative of f of x. And what we've just written, oh wow, look at that. We've seen that one before. What that's going to mean for us is that the function f of x is an odd function. And you can visualize all that goes along with odd functions. You can either take this guy, do the double reflection from here to here, and you'll see we match, or you can do the old spin test, and we see that it matches as well. Okay, let's look at one more function that you studied in Algebra 2 and get a little prepped on it. All right, so here's an example of a step function. I'm going to share some personal information with you guys. If I were to track over several years of my life here, how I answer the question, how old are you? I've summarized my answers here in a little chart for us to read. So let's take a look at the first one here. I'm going to input the date October 20th, 1995 into this function, which is graphed here. So we've got to find October 20th, 1995 right there. As we travel upwards, we see there's an open circle and a closed circle kind of right at that value there, but we know to obey the open circle And what that means is if you had come up to me on October 20th, 1995, if you were alive, and asked, how old are you? I would have said, I'm 20. So let's try a couple more of these. October 21st, 1995, just a smidge over, maybe one day later. Travel up here, and now you do see I'm on this flat part of the function, and even though I've aged a full day, I will still tell you that I'm 20. All right, I would like you to pause the video and try to fill in the rest of those values. Okay, welcome back. Hopefully you have come up with the same values as I have on New Year's Eve 1995, maybe somewhere around there. I'm still 20. July 4th, 1995. Sorry, 1996, but I'm still 20. October 19th, 1996. I'm right up against there, but I'm still 20. And naturally then, one day later, October 20th, 1996, I do get to jump up to the next level, and I get to answer that I am 21. And if you were able to do that math, you would be able to figure out, oh boy, October 20th, 2025. I'm not going to be 5. My age is 50 on that day. Okay? So that's a great example of something we call a step function. And when we want to input positive and negative values, we, it extends a little bit beyond just age reporting, and it is an actual mathematical function. So the symbol for this greatest integer function is the double brackets. And the way it works, if you plug in an integer, the output is the same integer. That's like finding me on my birthday and saying, how old are you? If you were to plug in a decimal or a fraction, the output would be the closest integer to the left, okay? That's what we call the Beyonce function, everybody. So I'd like you to pause the video and try your best to determine these 8 outputs to Beyonce's step function. Okay, everybody, welcome back. Let's take a look at how this all went. All right, thank you, Beyonce. So we've got a couple answers here, and just to go over a few of them to make sure we understand why, let's think of the value 1. 1 appears at an integer, the output is the same integer. But when we try 1.2, maybe just a little bit here, that is not an integer. Beyonce walks this to the left, and the very first integer that we do come up upon is a 1. When we try for 1.999, that would be right up against the 2 there, but not quite. And it's not a rounding function, it's a to the left function, and that would push that back left to a value of 1 as the output. Similar in the negative area here, the only thing we lose is the ability to relate it to age, but if you can just follow Beyonce and go left, you'll get there. So for example, negative 1.2 lives right there, not an integer. Send that to the left and you arrive at my output of negative 2. All right, let's just try one more of these. I'm going to highlight this because I know some of my crew likes to blow past the order of operations, but I hold it near and dear to my heart. So let's try to evaluate the step function here. 3/5 x plus 2 with an input value of 8. So I'll get you started. Okay. There's my function, blank where the x's go, and now let's input the 8. So I want you to pause the video. I want you to compute the value inside the double brackets, then send it to the left, and then subtract 1. So pause the video, see how it goes. Okay, welcome back. Here's how my computation fell after I tried the 8, multiplied 3/5 times 8, added 2, 6.8 in the brackets. Beyonce sends it to the left. 6 minus 1 is 5. Ta-ta!